Okay, so in another lecture, so today I'm going to cover briefly partial differential equations, but before that, um, I'm going to look at something what is known as power series solution for differential equations. I'll only take two examples, and this time I'm not going to do any theory, but if you want, it is available in the notes, right? So, because I have to sync both the sections, otherwise it will be difficult. Anyway, so partial differential equations are very useful, and the reason is that in many cases, whenever you are going to model something, so many times they are, it leads to partial differential equation, and actually also apart from that, quite often they are non-linear. And solving non-linear partial differential equations, not many techniques are available. Okay, so it's really challenging. It is so difficult that at one point of time Einstein also said that mathematics is still not developed well enough that we can have, so once we have the techniques for solving, different partial differential equations, so I think I still have a very nice book by a Russian mathematician on partial differential equations, which is sort of bit, so beautiful, I would say. Okay, so now recently Peter D. Lax, he got Abel Prize, so who is a leading person in this area of solving partial differential equations. So Abel Prize, I think at that point of time he got about $1 million. So a lot of scope for you if you develop expertise in solving partial differential equations. Of course, I am not going to do too much partial differential equation, as I mentioned in the last lecture also. This book by I.N. Sneeden, Elements of Partial Differential Equation, is a very nice, good introduction. Normally that is for mathematicians, but if some of you are excited, you can look at that book. And for engineers, there is another book, Partial Differential Equation for Scientists and Engineers. Now, so there are basically different kind of, so first order partial differential equation is something that is quite often studied, it's very easy. And second order partial differential equation, there are three of them which are, important one. So I am going to solve one of them using method of Fourier. It is also known as method of separation of variables. And two of them I will leave you to do it at your own pace, right? Technique is exactly similar. So there actually you assume that the solution of the partial differential equation is product of two functions, independent functions. You substitute into the equations, it leads to certain ordinary differential equations, solve them, multiply them, and then you get the answer. Okay, and depending upon the conditions. Okay, so normally this wave equation, heat equation, these are the common equations that are there, and Laplace equation. These are three popular equations that people study. So one of them I will solve, show you the technique, and rest you can do it actually. Okay, so now later on I will also touch something about Laplace transform. So these transformations are useful. So basically what happens, if you want to solve a differential equation and it's difficult sometimes, so what you do, you transform the equation to some other domain. Okay, and in that domain sometimes it is easy to solve, and then you come back. So loosely speaking, we can say that okay, there is a differential equation, there is a map phi which will map everything into some other domain, right? And there many times it is easy, and actually that is one very popular way of doing it. So I'll show you one example of that also. How do you use Laplace transform to solve a partial differential equation? Apart from that, some numerical techniques are quite often used. Okay, and as you know that I am only talking about integer differentiation, and you can look at partial differentiation, right? So alpha times, if you differentiate where alpha is a real number, So basically fractional differential equations are another interesting area, and they model many realistic phenomena, and there are not many techniques even in that area. Okay, so plenty of things for you to work on, and I'm sure when you are trying to model something, some of you are working on different interesting problems. You interacted with me, like modeling some phenomena, maybe, and then it will lead to some differential equation, right? So quite often non-linear. So if it's non-linear partial differential equation, I would say it's interesting. And as I mentioned to you, this approach of differential equation is one approach. Actually, we call it one of the mathematical approach. There are other modeling approaches as well. For example, one of them is stochastic pi calculus. Okay, so stochastic pi calculus, you don't have to write any differential equations. So what is happening actually? So if you want to model some event, you try to identify certain, so sort of quantify various parameters of that event. Okay, and then these parameters are dependent on each other in a complex manner, right? So one parameter might be dependent on 3 parameters, and one of those 3 parameters dependent on 2 other parameters, and so on and so forth, and they are changing. Okay, so the rate of some of these variables are changing with respect to time or something, right? So basically it will lead to, so when you try to model, actually it will lead to a differential equation. Okay, now so in stochastic pi calculus there is a program. So of course the simulator, there is I think the first simulator was done by Aviv Regev. She was at Harvard. I think she is still at Harvard, I guess, and she has written a simulator for that. So, and then there is another simulator written by Microsoft research team, Andrew Phillips, and there actually you can model. So basically what modeling is, bunch of parameters, their dependencies and their rate of change, right? That's all. In any model if you take, right? So you just capture that directly into the system in that program and simulate it, and you get the solution. So it is called as differential equation free world. Okay, so those kind of modeling techniques are also there. Essentially it's a computational techniques, right? Apart from differential equations and this stochastic pi calculus, there are some other techniques like cellular automata model. So CA, or block cellular automata model. So cellular automata is a beautiful thing used in modeling by many physicists initially. And there is if you want to know more about this cellular automata, you can look at this a new kind of science by Wolfram. Wolfram, that's a book. It's a very thick book. I think I have ordered one copy here in your library. It is available. It's a very thick book, more than I think 1,000 pages of maybe. It's beautiful. So so Wolfram idea is that this world, entire world, you can model in the form of cellular automata. Okay, so it's a very simple rule. So there is a tape and there are a bunch of bits. You can assume, say 0, 1, 0, 1, and these bits you can combine to give another bit in the next tape, and so on. So basically there are rules. Okay, and so these rules sometime may lead to even non-linear behavior or chaotic behavior, which is very, very interesting. Okay, and in fact I contacted Wolfram. I think he should be probably coming in Gujarat. Let us see, we are trying to arrange one thing. Anyway, so basically this is something interesting. So about cellular automata modeling, and in fact you see, so Wolfram initially wrote programs to do these simulations, and that led to the company Mathematica, also Wolfram Research now essentially. You see, so this is the beautiful application of mathematics that you can actually create out of it, right? Just trying to understand the nature. So there are two things: you want to understand the nature, and then you want to develop some technological solution to something. Anyway, so let me start with the power series solution first, and then we'll go over the partial differential equation. So as I mentioned, this book partial differential equation for scientists and engineers by Jeffrey Stephenson is something is enough for you. It's a beautiful small book, you know. So this you will find whatever we are covering. Otherwise, those 3 books, you know, that we have, especially these 2 books. हालांकि बुक बताने का कोई फ़ायदा नहीं है, शायद तुम लोग बुक पढ़ते नहीं हो, राइट? एक ये है और एक ये है. कितने लोग बुक पढ़ते हो वैसे? Not even a single person. This is the generation actually, you know. So I think now even if you want to understand about differential equation, you go to the chat GPT, type something, and you're believing that whatever chat GPT is giving is correct, right? And I think I can give you tons of problems for which chat GPT will produce wrong answers. Okay. So anyway, so that's something not good, but so these 2 books also have whatever we are covering here, right? In fact, I will give you one example from this book today. So as I mentioned, this book by Stephenson is something really nice. Okay, so okay, now let us look at this interesting idea. Suppose I want to solve this equation y dash is equal to y. Very simple equation, right? Now, so somebody thought that suppose solution is of the form a0 plus a1x plus a2x square plus dot dot an x raised to power n. This is a solution. So we say, normally we write, we seek a solution of the form this. Okay. What are AIs? I don't know. And suppose this series is convergent for some R. I don't know. I'll tell you what. You can compute R later on. R is the radius of convergence, positive, right? Suppose this is a solution. So this is equation 1. This is equation 2. Right. So I am saying that a series is a solution. AIs I don't know, right? But I can substitute and solve for AIs, right? I substitute this equation, this power series C, and I think you can see that this is the routine way of attacking the equations, right? Assume the solution of something like this, substitute if you are able to find, very, very well and good, right? If you are not able to find, okay, try some other method. So you just substitute it here, and then you observe that y dash will be a1 plus 2a2x plus 3a3x square plus n plus 1 an plus 1 x raised to power n and so on, right? This is equation 3. Now these 2 equations should be same because y prime is equal to y, right? So these 2, if you compare, now you can look at, we can compare the constant coefficients, power of x and so on, right? So a1 will be a naught, then 2a2 is equal to a1, right? Because the power of x is same, right? Similarly, power of x square should be same. So essentially what we are getting, a1 is equal to a naught, 2a2 is equal to a1, 3a3 is equal to a2, and so on, n plus 1, an plus 1 is equal to an. Right? I can compare. Because y dash is equal to y, it is given. So these 2 power series I can compare. Right? So the coefficient should be same. So once we have this, now you see, observe it's something really interesting. The coefficient a naught, of course, so I am not able to find the value of the coefficient a naught, right? So I need to take it a constant, there is no other choice. But a1 can be expressed in terms of a naught. What about a2? a2 is a1 by 2 and a1 is a naught, so a2 is a naught by 2, right? What about a3? Can you tell me what is a3? a3 will be a naught by 3 and then you can use the value of A2, right? So it is what? A0 by factorial 3, correct? A4 is A0 by factorial 5, and so on, right? So now we have y is equal to A0 1 plus x square by factorial 2 plus x cube by factorial 3. Do you agree? Right? ये पहला कोफिशिएंट हो गया A0. सेकंड क्या था? A1 was A0. This is A1, which is A0, right? And this is A2, which is A0 by factorial 2. तो A0 हमने कॉमन ले लिया है सब में, right? So we have got this expression. अब ये सीरीज तो दिख रही है तुमको, पहचानी हुई, e raised to x. आ गया ना ब्यूटीफुल सोल्यूशन, राइट? पावर सीरीज मान करके सोल्यूशन निकाल लिया, राइट? So we know that the series is convergent for every x, right? So essentially this is nothing but A0 times e raised to x. A0 को तो एलिमिनेट नहीं कर सकते हैं, एक कांस्टेंट तो आएगा ही, बिकॉज द ऑर्डर इज 1, राइट? सो दिस इज द सॉल्यूशन, राइट? ब्यूटीफुल. Look at another example. Okay, this time y double dash plus y is equal to 0. I am taking only simple examples, you know, I can take more complicated ones, but at least try to understand what is happening. Okay. So again, we seek solution of the form y is equal to a0 plus a1x plus a2x square plus dot 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 an x raised to power n plus dot 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 dot. इसमें सब्स्टिट्यूट कर देंगे, राइट? सो y प्राइम विल बी व्हाट? a1 प्लस 2a2x plus 3a3x square and so on, n plus 1 an plus 1 x raised to power n and so on. Y double prime will be 2a2 plus 2 times 3a3 plus 3 into 4 times a4 times x square and so on, n plus 1 n plus 2 times an plus 2 x raised to power n and so on. Right, we can differentiate. एक बार differentiate किया, दो बार differentiate किया. Now we know that from that equation the sum of these two things should be 0. So इसका मतलब क्या होगा? 2a2 plus a1 is equal to 0. पहला coefficient जब लेंगे, right? Similarly we can take the second coefficient. The कुछ गड़बड़ है ना? x missing है, right? Right. So we can compare second coefficient and third coefficient. So essentially what we are going to get is the following. So we will be having 2 times a2 plus a0 is equal to 0. 2 times 3 times a3 plus a1 is equal to 0. Right. 3 times 4 times a4 plus a2 is equal to 0. 4 times 5 times a5 plus a3 is equal to 0. Just adding the coefficients and putting equal to 0, right? And finally we should have something like this: n plus 1 n plus 2 an plus 2 plus an is equal to 0. ये power of x power n की power रहेगी, right? Now, so this will give us from this a2 is equal to minus a0 by 2. Right. अब now you can see that a2 की वैल्यू निकाल ली a0 में, a3 की वैल्यू a1 में आ रही है, and there is no relationship between A1 and the previous one, right? So इसका मतलब दो constant आएंगे इस बार, right? I can express A2 is this, A3 is minus A1 by 2 into 3, A4 is minus A2 divided by 3 into 4 is equal to A0 divided by 2 into 3 into 4, A5 is equal to minus A3 divided by 4 into 5 is equal to A1 divided by 2 into 3 into 4 into 5, and so on, right? Right? So now there are two constants, either coefficient is expressed in terms of A0 or A1, right? You can continue like this. So that means I can separate these two coefficients. So basically solution will be A0 1 minus x square by factorial 2 plus x raised to power 4 by factorial 4 minus plus A1 times x minus x cube by factorial 3 plus x raised to power 5 by factorial 5 minus and so on. Everything expressed in two coefficients A0 and A1, right? अभी बता सकते हो ये कोफिशिएंट जो ब्रैकेट के अंदर लिखा हुआ है ये क्या है? एक साइन है, एक कॉस है. तो आ गया तुम्हारा y डबल डैश प्लस वाई इज इक्वल टू 0. कितना ब्यूटीफुल सोल्यूशन है. अप्रोच देखो ना, पावर सीरीज माना, सब्स्टिट्यूट किया, यू नो, राइट. So this could be y1 of x, this could be y2 of x, and both are series which are convergent. So convergence is very very important. You need to check, right? अगर convergent नहीं होगी series तो solution होगा ही नहीं, right? So I mean, so that means the solution is valid only for the values of convergent when the series is convergent, right? So it is convergent for every x here, no issue, right? So y is nothing but a0 times cos x plus a1 times sin x. Okay. So like that you can solve. So sometime what happens, you see again, if I take some more complicated equation, you will try again the same approach. Sometime there will be a problem. You will arrive at some problem that you will not be able to solve. Then any idea what should we do? One very popular technique that you might have learned. ठीक है, पावर सीरीज पूरी काम नहीं कर रही है ना, उसको पूरे को x से मल्टीप्लाई कर देते हैं और x की पावर m से मल्टीप्लाई करते हैं और सब्स्टिट्यूट करके देखते हैं क्या आता है. All this, you know, thinking, okay, because normally what happened, if you remember, when we solve the equations, you know, sometimes that x is matters, right? So normally the technique when with the roots are, you know, equal, right? The second order equation, so is the coefficient. So auxiliary equation has two roots, m1, m2, so m1 is equal to m2 is equal to m. In that case, solution was c1 plus c2x times e raised to power mx. एक कोफिशिएंट, एक सॉल्यूशन था c1 times e raised to power x, दूसरा था x times, right? That x factor matters a lot, right? So this is very common. So you know, one can try other things. So basically, when you do those kind of things, it results to a algebraic equation known as integral equation, and solving that will give you different ways how do we do this. This is a very very powerful technique, and power series solutions has been used to compute solutions of say Bessel's equation, a lot of special functions. You know, maybe I can show you the, you know, I'm not going to prove anything now, but I can show you the equations. Okay, so if you go here and yeah, you see, can you see? Is it visible? इसको हटा दिया. Is it okay now? So you see, I told you about these solutions. Now you look at some of the series solutions. So there are some conditions when these coefficient functions are well behaved, then only we can look for these. If there is a singular point, one has to change the approach. See, for example, this equation. 1 minus x squared times y double prime minus 2xy prime plus p times p plus 1 times y is equal to 0. Solution of this equation is known as Legendre equation. This is the Legendre equation. And then you see, we again put y is equal to sigma a n x n into the equation. Y prime is this, y double prime is this, and then you can just compute. Technique is exactly similar. And this leads to following relationship, right? And you get, this is the solution. See, such a complicated solution. Technique में कोई फर्क नहीं आया अभी, right? You just substitute the power series solution, do differentiate, put it into the equation, and then, so there are two solutions. अगर एग्जाम में मैं पूछूं कि ये दो solutions linearly independent है, कर लोगे ना, Wronskian? I mean, dependent तो होंगे ही ना. Otherwise it doesn't make sense, right? So something like that can be asked, right? Ultimately full marks पे जो है ना, double A भी तो दे सकते हैं ना. So think about it. Something not very difficult, but yeah, series solution, right? It's a formal solution. Okay, let me show you a couple of other. There is a definition. See, now here x is equal to 0 is a singular point. Then we need some other modifications. So this equation is known as Bessel's equation. So by the way, these special functions are very, very important. And if you are really excited about special functions, which I think you should, there is book, handbook of special functions. काफ़ी मोटी किताब है, 1,500-2,000 पेज की किताब है. So you will love it actually. Okay, full of special functions. The solution to these kind of equations actually, are interesting. And many times these solutions have some recurrence relation. Okay, एक solution लिया और फिर for parameters change किया और उनमें आपस में relation होता है, right? So that is something interesting. Okay, so this is the Bessel's equation. You see here you see near the regular singular point x equal to 0, we take y is equal to x raised to power m times power series. Okay, as I mentioned, and then you substitute, solve for everything, right? The same technique. So this is useful in Euler's equation like this. Okay, and yes, I think that's all about series solution. I mean, we should have covered this, but it's okay, See, if you are really interested, you can read this stuff. Because we just sync with the other sections, so I cannot do it. Okay. So this is really interesting. I mean, this is very important. I think you will see some of the exams I have asked this Gauss hypergeometric equation. So power series, right? Power series, like 1 plus x square plus x square, 1 plus x square plus x cube, right? 1 over 1 minus x, the power series, right? So I mean, those things can be generalized to what is known as with certain parameters of a, b, c, and that comes out to be a solution of this equation. So known as, this was discovered by Gauss, hypergeometric series. So basically, geometric series is a generalization of the geometric series. So I think I can show you. You seek the solution like this, do the coefficient arrangements, and here is the function. So solution turns out to be 1 plus, so you see that if A is 1, if you put A is equal to 1, I think, yeah, if you put A is equal to 1 and B is equal to C, what you will get? A is equal to 1 and B is equal to C, सब कट जाएगा और आपकी power series आ जाएगी, geometric series. Okay, so this is the general solution. So actually we denote it like this. a into a plus 1 into dot 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 a plus n minus 1, we call it a going n times b going n divided by factorial n times c going n, right? So we denote it like this. A going, sorry. Okay, I cannot write it here, no problem. Okay, so this is known as hypergeometric series. You see 1 over 1 by x. If a is equal to 1 and b is equal to c, we get the geometric series 1 plus x square plus so on, infinite series, right? So these series solutions are really useful, right? Once you have differential equation, assume that solutions of the form a series, substitute it and solve it, okay? And now you can see that there are some interesting relationship also. And so basically the solution of a Gauss hypergeometric equation is in the form of these two series solutions, f a b c x and f a minus c plus 1 b minus c plus 1 2 minus c and x. So all the details I am leaving, no issue, right? Okay, so that's all about power series. Now we are ready for partial differential equations, I guess, right? So I think still we are ahead. So let us look at partial differential equation. Partial differential equations, right? So basically equations of the form x, y, u, ux, uy, uxx, uxy, uyy, and so on. A relationship of these variables is nothing but a partial differential equation, right? What is x? Independent variable. Y is independent variable. U is a function of x comma y, right? And then we also have partial derivatives of u, of first order, second order, and so on, right? You can have higher ones also. So this is nothing but a partial differential equation, right? In general. So now how we'll find them? Suppose u of x comma y is x minus alpha whole square plus y minus beta whole square. Find the partial differential equation having this as a solution. So remember, if I say that y is equal to sine x, find the equations, you know that the equation is y double dash plus y is equal to 0, and that you can just differentiate, add, and you get. So basically you try to eliminate, right? Here also the same thing. So del u over del x will be what? 2 times x minus alpha, and del u over del y is nothing but 2 times y minus beta. Right? So now I can just substitute these things here back. We get u is equal to 1 by 4 del u over del x whole square plus 1 by 4 del u over del y whole square. This is a partial differential equation because it involves a function u, del u over del x, and del u over del y, right? This is a relationship between all these parameters, right? So this is the partial differential equation. Any question? Normally मैं ही बोलता रहता हूँ, तुम लोग तो कुछ पूछते ही नहीं हो, right? So ये basically it's like DTH ना, so Tata Sky kind of thing. But आजकल तो interactive का जमाना है, right? So you should ask. Okay. Anyway, so this is all partial differential. So given this kind of two variable function, you can find the partial differential equation. That is not a difficult thing to do. So as an exercise, I am giving you, suppose uxy is a times x plus b times a times x plus b times y plus a square b square. I hope you will be able to find the partial differential equation, right? Sometime equation is given, I mean sometime basically solution is given and you have to verify that it's a solution of the partial differential equation. You can just substitute, right? Just substitute the function into the equation, and if it satisfies it, it is a solution. If it doesn't satisfy, it is not a solution, right? Okay. Now, first order PDE. A function of the form x, y, z, p and q. Z is a function of x comma y and p is del z over del x and q is del z over del y. This is the first order differential equation, most general form, right? A relationship between x, y, x and y are independent variables, z is a dependent variable on x and y, and we have p and q. P is del z over del x and q is del z over del y, right? There are different techniques known as Charpit's method and so on. I'm skipping that, the first order things, right? But rather I'll show you what is second order differential equation. A times uxx plus 2b times uxy plus c times uyy plus d times ux plus e times uy plus f times is equal to g. This is the, first of all, this is linear partial differential equation, second order, because all the derivatives are involved are second order, uxx, uxy and uyy, and first order derivative is there anyway and the function is there, right? So this is the whole typical second order linear partial differential equation with in two variables, x and y, right? So there is some classification known for these equations. They call it hyperbolic, depending upon the some relationship between a, b, c. So the classification says that. So normally normally we convert it into what is known as characteristic polynomial p alpha beta, which is a alpha square plus 2 times b alpha beta plus c times beta square plus d times alpha plus e times beta plus f, just like a operator, right? So this is something like a characteristic polynomial. These are used. I am not actually solving any of this, but it will give you classification. So if b square minus ac is positive, equation is called hyperbolic, right? If b square minus ac is 0, it is known as parabolic, and if b square minus ac is negative, it is known as elliptic. So this is the classification. So based on these coefficients from this second order partial differential equation, I can compute. Essentially, it has something to do with when we solve. I'm not giving any technique to you, and convert it to algebraic equations, right? So then there are conditions. Okay. So as an example, suppose we take 3 times uxx plus 2 times uxy plus 5 times uyy plus x times uy is equal to 0. So here B square minus AC will be what? 1 square minus 3 into 5, which is minus 14, and it's a negative. So this is elliptic. So this kind of classification can be done. So I have not given you any method of solving second order partial differential equation. I have not given any method for solving first order. It is there, but I think, as I mentioned, I have to sync. I'm sure that they will not be able to cover. So basically I need to make sure that we are on the same path. Anyway, so, but what I'm going to give you, I will take three kind of equations which are, say, hyperbolic, parabolic, or elliptic, and I'll show you the method of separation for one of them actually, okay? So you know that how do we solve it. Okay, so we call it a special partial differential equation. This is something really important, and you should know this technique. So del u over del t is equal to c square del s square u over del x square. This is known as one dimensional heat equation. Why they are called it like this? And actually it's a parabolic equation. So this is one dimensional. Two dimensional will be del u over del t is equal to c square del u square u over del x square plus del square u over del y square. This is two dimensional heat equation. Why call it heat equation? Actually in the rod they are trying to study the heat, how it goes from one to other place, right? And that model came in terms of this partial differential equation. So I think in terms of applications, I think similarly we can go for the three dimensional heat equation, right? I'll have another component. So one dimension, two dimension, and three dimension. Okay. Second one is when you say del square u over del t square is equal to c square del square u over del x square. This is known as one dimensional wave equation. All these three are very, very important. Similarly, we have two dimensional plus del square u over del y square. Two dimensional wave equation. Right? And this is your hyperbolic in nature as per the classification. Okay? And the third one is you are actually familiar with. It's the elliptic equation. And actually it is, I am denoting two dimensional Laplace equation. Equation is del square u over del x square plus del square u over. Are you familiar with this equation? If f of z is harmonic, उसके component ये equation satisfy करते हैं. You remember Laplace equation, right? So these are the three important equations originated from different applications when we are looking at wave phenomena, right, or the heat conduction, right? So simple hai, you know, I mean, one can explain this, but I'm not going to do this. But in a rod, how the you know, you can assume certain parameters and then you study the flow of the heat, right? And that results into the differential equation. So right now I am worrying about how do we solve any of these equations, right? And the technique is exactly similar. Okay, so what is the approach? So method of separation that we are going to use. Okay, so basically what you do in any of these three equations, we know that the solution is of the form like this, right? Where x and y are independent variables and uxy, you can call it z, right, is a dependent variable, right? So we assume that solution is of the form product of two functions x and y. X is only function of x, y is only function of y. So product of two function is this. Then del u over del x will be what? Del over del x of x into y is equal to x prime y. Agree? Because differentiation only with respect to x, right? Similarly, del u over del y is equal to x times y prime, and del square u over del x square is equal to x double prime times and so on. So what is x prime? Dx over dx, and y prime dy over dy. Right. So basically, assuming that the solution is of the form product of two functions, this is at only function of x times only functions of y. Just substitute and then solve. This is the very powerful technique. I think today we don't have enough time, but in the next class I will do example for this, right? So how do we approach this? So this approach is very similar in all the three methods. Assume the function is of this form, substitute it, it will result into ordinary differential equations and solve it. Okay. So that's about method of separation of variables. I think it will take, so normally PD is only one class is enough, but so I think another probably 15 minutes or 20 minutes in the next class will be enough. By the way, I am here. So when is the next class? Monday I am here. So what is the date? 4th there. So I am now leaving on 8th. So I think we are getting 3 extra lectures for you, right? So good. So basically, if you want, we can cover more stuff, right? So for exam, you will have enough stuff, right? To thanks that I have changed.